So this is 2025 paper 1 question 3, and we're given a function here and we're asked to differentiate it to find f prime of x. So the way we do that, if we find f prime of x, well, here we have a function inside a function. So 3x to the 5 minus 4 is a function, and then we're taking that function and we're raising it to the power of 28, which raising something to the power of 28 is a function as well. So the way that we deal with this, we use the chain rule. So we take the derivative of the inside function. So we're going to get 15x to the power of 4 using the power rule. Then the derivative of minus 4 is just 0, so we don't need to write that. And now we've taken the derivative of the inside, so we're going to take the derivative of the outside function and keep the inside the same. So the derivative of something to the power of 28 is going to be 28, and then keep the inside the same. And then reduce the power by 1, giving us 27. And they say we don't need to simplify our answer, so that is good. For part B, we're given a different function, and we're told to find the derivative g prime of x and use that to show that it has no local maximum or minimum points. So remember that local maximum and minimum, that is when g prime of x, the derivative, is equal to 0. So let's find the derivative of this thing and let it equal to 0 and see what happens. So there's a few ways you could use this. You could use the chain rule or you could use the quotient rule. I'll use the quotient rule because it's probably more straightforward. So if you go to page 25 of the Formulae and Tables booklet, you'll see the quotient rule here, which I'll write down. So here, u is the top function, v is the bottom function. So here, u is equal to 3. So the derivative of u with respect to x will be 0. And here, v is equal to 2x minus 7. So the derivative of v with respect to x will just be 2. And then we can just sub into this formula. So again, y equals u over v. That's the same as just saying the derivative dy over dx. In this case, we're just using g. So we're just going to say g prime of x equals. Then we're going to have v, which is 2x minus 7. Multiplied by du over dx, which is just 0, minus u, which is 3, multiplied by dv over dx, which is 2, all divided by v squared. So it's going to be all divided by 2x minus 7, the whole thing squared. And remember that once we get the derivative to find the local maxima and minima, we set that equal to 0. And let's see what happens now. So we're going to have minus 6 over 2x minus 7, the whole thing squared, equals 0. So you could try to multiply both sides by 2x minus 7 squared, but you'll see when you do that, if you multiply this up to the right side, what you would get is you get minus 6 equals 0, which obviously isn't true. So why is that? So again, the question asks us to show that there is no local maximum or minimum, and it should make sense. So here we have a number divided by a number, and that's equal to 0. That's actually never possible. No matter how big you make this number, it's still just going to be a really small number. You can't actually make the denominator anything to make the whole fraction be equal to 0. So one way you could say this is you could say this can never be 0. This can never be equal to 0. Another thing you could see is that this slope, g prime of x, it's negative and the bottom is squared, right? So whenever you square a number, it's going to be, again, you don't have to do this way, but it's interesting to look at. The bottom, when you square it, it's always going to be positive. So we're going to have something negative. So g prime of x is always going to be something negative over something positive. So that means that the derivative is always going to be negative. So it's always going to be a negative. So that means that it's always decreasing. So if it's always going down, it can't have a local maximum or a minimum because it's always moving downwards. There's no point at which it turns around, so it has a maximum or minimum. So you could also argue it that way, that the derivative is always less than 0. You could say g prime of x is always less than 0. Therefore, no local max or min. But the first way is okay as well. I just think this is a good thing to understand for your understanding. In part C, we're given an integral and we're told to find the value of k. So if you go to page 26 of the Formulae and Tables, you can see here we have e to the power of 5x. So that's like e to the power of ax as we have here. And the integral of that will be 1 over a e to the ax. So here we can apply that. So the integral between 0 and k of e to the 5x dx, well, that's going to be equal to 9. Now we can figure out what this integral is here, again, using that rule there. So we're going to have 1 over a, in this case a is 5, so we're going to have 1 over 5, and we're going to have e to the power of 5x, and then remember we're evaluating that between 0 and k, and that's equal to 9. So I'll get rid of this now, and let's solve this equation. So we're going to have 1 over 5 e to the kx, or sorry, to the 5k, we're replacing all the x's with k, minus 1 over 5 e to the 5 times 0. And don't forget to sub in that 0 because it's important. A lot of people would leave that out. Equals 9. So we can multiply everything by 5, or we can simplify a bit first, kind of up to you. I guess I'll simplify first. We'll have 1 over 5 e to the 5k minus 1 over 5, and then we have e to the power of 0, which is equal to 1. So that's just going to be minus 1 over 5 equals 9. And now we can multiply across by 5. And we can say that e to the 5k minus 1 is equal to 9 by 5 is 45. So e to the 5k is equal to 46 by bringing the minus 1 to the other side. We can do ln on both sides. So if we do ln on this side and we do ln on this side, ln and e to the power cancel out, and we'll get that 5k equals ln 46. And then finally, k is equal to ln 46 over 5. And they told us to give it in the value ln a over b, where a and b are natural numbers, and we did that, so we are done.